Okay, chalo. Sorry for the delay. The thing is, your app, something maintenance is going on. Because of this problem, I have to run here and there. Anyways, let us continue with trigonometry, what we were doing. Next, the first 5 or 6 lectures of trigonometry are very crucial lectures. Okay, if this is clear, then the remaining part of your trigonometry is also clear. This particular lecture of these first of 5 to 6 lectures of your trigonometry, the first 5 and 6 lectures are very crucial. Apart from which the things are there, other than that, those are very advanced things. Those are just the applications of these things, whatever you are doing. Okay, so these things are very important and you must be knowing these important things. So continuing the reduction formula thing only, let us see the other reduction formulas. The reduction formulas, okay. Try to visualize things. What I will say right now, you need to visualize the things. Okay, do not just simply memorize the concepts. Basically, you need to visualize also. Okay, better to visualize just by simply remembering. You will see a lot of formulas are given, extra formulas are given. Why to remember so many formulas? Just to understand the concept will simply help you. Okay, just remember the concept. Even I also avoid remembering so many formulas over there in trigonometry. Base formulas you have to remember. You do have to remember what are the base formulas. I have told you fundamental identities, faster calculations, for basic identities are there. Other than these things, the formulas are there which you need to remember. So let us recall first of all what we have done in the first class. I think we have done 90 minus theta, right? I think we have done the reduction formula for this 90 minus theta, isn't it? This is what we have done in the last class, first class most probably. Yes, sine 90 minus theta or cos 90 minus theta. That all of you know this thing, sine theta, cos theta. So we are going to see the reduction formula for the other angles also. What we used to do basically, we used to create the circle of radius r. Basically does not looks like one. Circle of radius r. Okay, and circle of radius r. This is the radius. We used to consider this. This is r. Okay. This coordinate we used to consider, this is coordinate x comma y. So basically this distance used to be x and this distance used to be y. This is what we have seen. Okay, and in case of that 90 minus theta, basically 90 minus theta, to create 90 minus theta, this angle used to be theta and we used to create a similar diagram purposely in such a manner. I told you how we'll create the diagram in such a manner that we purposely create one angle of 90 minus theta over here. Why we create this thing? Because if this is 90 degree, so as this angle will be 90 minus theta, isn't it? If this is theta, this is 90 degree, so this angle will be 90 minus theta. So purposely in the second diagram we create 90 minus theta at the origin. Okay, this is just the recap of what we are doing actually, what we were doing in the last class. Recap of what we were doing. So this was 90 minus theta. Okay, and we are actually purposely creating 90 minus theta at the origin, and in that case we have this angle would have been theta. This angle would have been theta because this was 90 degree, isn't it? Automatically by ASA congruency, basically this would have been this particular, if this is theta, then the front side of theta, this would have been x, this would have been y, sorry. Why? Because over here theta's front side over here, theta's front side, what is theta's front side? This is y. So over here corresponding to this theta, the front side of theta, this would have been also y. Okay, by ASA congruency, these two triangles are congruent triangles. Okay, so throughout these proofs actually we are going to see the congruent triangle proof only. Okay, that two triangles are congruent by ASA. I have shown the proof also, and these two are congruent triangles, so as this particular thing, so equal sides opposite to equal angles are equal. So this opposite side of this particular angle theta will be y. So as this particular theta is over here, so the opposite side, this particular side would have been y. Similarly, if this particular angle is 90 minus theta, so as this particular angle is 90 minus theta, so opposite side of 90 minus theta is x, opposite side of 90 minus theta over here, this much particular distance will be x now. So automatically this particular coordinate in the place of x comma y now simply turn out to be y comma x. This is what we have seen so far. Okay, this particular logic we have seen in fact. So gradually over here we have derived this particular formula. Just a second, let me increase the brightness of my screen. Yeah, So this particular thing over here, we have 90 minus theta. So as we have derived the formula for sine 90 minus theta. In the first triangle, we have sine theta. Sine theta would have been, what is sine theta? Y by r. Y coordinate upon r. Simple, remember in this manner. Y coordinate upon r basically. Y coordinate upon r. So y coordinate, sine theta will be y coordinate upon r, right? Okay, perpendicular by hypotenuse. So over here, and cos theta in the first triangle was x coordinate divided by r. But over here we have, because we have, this is 90 minus theta, so that you are getting sine 90 minus theta. Sine 90 minus theta, from here sine 90 minus theta will be, perpendicular is now x, so x by r. But what was x by r previously? Cos theta. So this is cos theta. So sine 90 minus theta, you are getting cos 90 minus theta. This was the proof how we have done. This is, up till now we are simply doing the revision of what we have did in the last class. Cos 90 minus theta is y by r. From here, this will be base by hypotenuse. So base is, in this case, base is y actually, right? Base is y. So this is actually y by r. So y by r over here, we have previously we have y by r to be sine theta. So we are getting sine theta from here. Okay. This is just a recap I am doing because I know that your last lecture was not uploaded yet because of this problem in the app. So that's why I am repeating this thing over here. Okay. This particular concept. Just to proceed with the further concept, I'll proceed the further concepts also, the reduction formula for 90 minus theta. I told you why we call this to be reduction formula. Why? We have 90 minus theta. We want to convert this into theta. We don't like 90 minus theta or bigger angles of such types. Okay. So that's why we convert into theta. That's what our purpose is to do over here. That's why we call this to be reduction formula. We are reducing something to this thing. Now, proceeding with this particular reduction formula itself, this was the first reduction formula. You may give this part number A, suppose A is the first one we have for 90 minus theta. Okay. These are all reduction formulas. You take down the proofs also. Proof will also help you in understanding geometry concepts also. Although you don't need the proof, I am explaining the proof right now. In the previous, few years of batches I have seen in the offline batches, I do not used to just show these proofs and all, only overall concepts. Okay, only overall concepts I need to explain. But over here, what I feel, this batch is a strong batch this year. Okay, your batch is a very nice batch, so I'm explaining these standard proofs over here. Same thing goes for the other proofs also. Come to this one, next one, 90 plus theta. Reduction formula for 90 plus theta. What will happen for reduction formula for 90 plus theta? Okay, so I do the same logic over here. I take the circle. Logic will be the same. I will take the circle of radius r. Okay, a bigger circle, suppose I am taking. So circle of radius r. So basically I am taking the radius r over here. Let's say here. Okay, this is circle of radius r. All of you know, if you drop a perpendicular, this much distance will be x. Okay, this much will be y, and the coordinate of this thing will be x comma y. Okay, coordinate of this thing will be x comma y. Now this is theta actually. This is theta. This is theta over here. What we need 90 plus theta. So gradually you have to locate first where is 90 plus theta. Okay, you have to locate first where is 90 plus theta. So obviously over here you can visualize from this particular diagram itself, if this much is 90, okay, plus theta, 90 degrees plus theta. So this much is 90, so plus theta will be somewhere over here, right? Plus theta you have to move somewhere over here, right? 90 plus theta. So gradually your theta will be, basically this is your 90 plus theta. Somewhere over here, basically you have to create the triangle. Okay, likewise you will create the triangle in this manner. I extended the arc basically. The thing is you have to create the triangle in this manner. Here actually you will drop the perpendicular. Understanding, if this is theta, then this much is 90. So 90 plus theta, so plus theta, somewhat theta we are going. So this entire thing is your 90 plus theta. This entire distance will be 90 plus theta. And you are dropping the perpendicular. So gradually over here, you will drop the perpendicular over here in the second quadrant. Okay, in the second quadrant. Understood this part? What we are actually doing actually. Okay, if this is 90 plus theta, this is theta. So gradually this much is 90 degrees. right? If this is theta, this is 90 plus theta, entire thing is 90 plus theta, simply subtract this particular thing, so you will get what? This much will be 90 degrees, isn't it? This much will be 90 degree. Clear? Okay. The first thing what you need to do, you need to locate first where is theta. You need to locate first where is theta and then the other angles. Obviously, this is a 90-degree triangle which you have created. Okay, this is 90-degree triangle. Now the question is, what is this angle? This is 90 degree. Entire thing is 90 plus theta. This is theta actually. So can you tell me what is this particular angle? What is this particular angle? What is this particular angle? Can you tell me? What is this particular angle? I have told you this is 90, this is 90 plus theta. Okay. Entire thing is 90 plus theta. Okay. 90 minus theta. Why? No, not 180 minus theta, 90 minus theta. Why it is 90 minus theta? Which thing? What we are using actually? Simple idea, 90 plus theta, this much is 90 plus theta, entire thing. It is wrong, not 180 minus theta. This is 90 plus theta, all total. Okay. Exterior angle is actually sum of two opposite interior angles. Okay. Exterior angle is basically sum of two opposite interior angles. Okay. So gradually the upper angle, this particular angle will be theta, and this is 90 minus theta. Yes, simple. 180 minus 90 plus theta. This particular angle will be 90 plus theta. 90 minus theta, sorry. This particular angle will be 90 minus theta. Clear with this? Exterior angle is actually sum of two opposite interior angles. So if this is 90 minus theta, this is 90. So gradually this is also theta. Anyways, simple idea. Now for theta again for this theta, again we have this ASA congruency. ASA congruency means in front of theta, if this is theta for this triangle, if this is theta, suppose, if this is theta, then the front side is what? Front side is y. So if this is theta, automatically this front side will be y. And if this is theta, sorry, 90 minus theta. What is 90 minus theta in this case? This much was 90 degrees, so this much was 90 minus theta, isn't it? This much was 90 minus theta. So obviously, if this is y, so gradually this is also, this is x basically, isn't it? This is x because this was 90 minus theta. This was 90 minus theta, 90 minus theta ka front side. 90 minus theta's front side is actually x. So 90 minus theta over here, corresponding front side is this. So this much will be x. Okay. So you need to figure out what is this coordinate anyhow. You need to figure out what is this coordinate anyhow. What is this coordinate? How much is this coordinate now? Minus y comma x. Minus y comma x. Because we are there in the second quadrant. Okay. This y is actually lying on the x-axis. Second quadrant, x is negative. Okay. X coordinate is negative. No matter whatever it is. Here we have in the place of x coordinate, basically y is there situated in the x coordinate basically. Okay. So this will be minus y comma x. Is this concept clear till now? Whatever we have discussed. This coordinate you have to just derive. Minus y comma x. Is this clear? Okay. Lot of things I have explained. Okay. All basic things we have overall. So in this case, y is negative because we are on the x-axis. So y is negative. So gradually in this case, what we need? We need to figure out what? We need to figure out what is sine 90 plus theta. We need to figure out what is sine 90 plus theta and cos 90 plus theta. We need to figure out these things. And then gradually you can figure out what is tan 90 plus theta also. That also I'll explain. So sine 90 plus theta will be what? From this particular triangle. Come down to this pink triangle. From sine 90 plus theta, this will be x by r. This is r actually. This is r. Okay. So x by r. Perpendicular by hypotenuse. So we have x by r. Okay. But what was x by r originally? X by r was cos theta. X by r was cos theta from this particular diagram. From this diagram, x by r was what? originally x by r was cos theta. Always remember this thing, sin theta is y by r, cos theta is x coordinate by y, r. Okay. So sin theta in this case, sin x by r will be cos theta, x by r will be cos theta. Originally x by r was cos theta. So sin 90 plus theta, we have got sin 90 plus theta is cos theta. Okay. Sin 90 plus theta is cos theta. I'll show you the difference also, how to, like, you will not, in the exam, you will not create so many triangles and simply see. So shortcut way is also there. That is also, I'll show you very shortcut way to visualize these things actually. Okay. So what is cos 90 plus theta? Once again, cos 90 plus theta. Here we have cos 90 plus theta. So see from here itself, cos from this particular triangle, cos 90 plus theta will be y by r, y coordinate in this case, in this triangle basically, base by hypotenuse. So base is y, so y by r. Now y is what? Y is negative. Y is negative. So minus y by r. Y is negative in this case, so minus y by r. Okay. Now originally y by r was sin theta. So we have minus sin theta. So cos 90 plus theta is equals to minus sin theta. Originally this was sin theta, y by r was sin theta. So cos 90 plus theta is sin theta. This is the proof actually. Is this clear? Sin 90 plus theta is clear? Bolo. Proof is clear. Overall the concept you just need to know, but this is the proof actually. This is a standard proof actually, using geometry and all. This is a standard proof. Overall though you just need to see the quadrant, and just for you just need to see the quadrant, locate the radians over there, which quadrant it is lying, and then you have to see the. I'll show you the shortcut also. Now come down to C. Now come down to the reduction formula for 180 minus theta. 180 minus theta. Reduction formula for 180 minus theta means what we need to figure out. We need to figure out what is sine 180 minus theta or pi minus theta. Sine pi minus theta and cos 180 minus theta, cos pi minus theta. These things we need to figure out. All of you know, in case if you have studied trigonometry, then you will know this thing, sine pi minus theta. Then this will be sine theta itself. Okay. Because this will lie in the second quadrant. Second quadrant sign is positive. Anyways, I'll show you the shortcut. That's the shortcut I told you. So, first of all, again the same logic. What we do? Create the circle of radius r. Okay, bigger circle suppose I am taking. Okay, for my convenience to draw. First of all, so you need to locate where is sine 180 minus theta. Sorry, 180 minus theta. Simple 180 minus theta. You need to locate where is 180 minus theta. How is 180 minus theta situated? Okay, this is first what you need to figure out. How is 180 minus theta located? So total is 180. Suppose over here what you used to do first, we used to take this triangle. Okay, this is coordinate x comma y. This is y. This much distance is y. This is x. This was theta, originally theta, and this much r. Radius of the circle basically. Okay, what I need to figure out? I need to figure out where is 180 minus theta located. So obviously complete rotation is 180. Complete rotation means not complete rotation. Half the rotation is 180 degrees. So 180 minus theta. So total 180 we won't go. 180 minus theta means over here, all of you can see this. If this much distance, I'll show you. If this is this angle is theta, then this much distance will be 180 minus theta. This is 180 and 180 minus theta means somewhere over here itself. Okay, 180 minus theta. So I'll remove this part, 180 minus theta. Somewhere over here we have 180 minus theta. Okay, triangle will be somewhere over here. Okay, so this much distance, this is actually theta, so this much distance will be 180 minus theta. This is 180 minus theta. Okay, total is 180. 180 se thoda kam, just something less than 180. Something less than 180. So 180 minus theta, somewhere over here we have 180 minus theta. So triangle will be situated in this manner. Okay, triangle will be situated in this manner. Understood? This is the way of just drawing the triangle over here. Now the things what you need to do over here. Means basically first thing what you need to have is, first is you have if this is theta, basically this is 180 minus theta. So gradually this particular angle will be also theta. This angle is also theta, right? We are first creating theta. Okay. This much distance is 180 minus theta. This is 180 minus theta. So total this particular distance will be what? Only theta. 180 minus theta. Only theta. Okay. You need to figure out what is this particular coordinate. If this coordinate is figured out, then easily we can find out what is sine 180 minus theta and cos 180 minus theta. Okay. With respect to this particular theta. Okay. So now what? If this is automatically, you are getting this is theta, right? If this is 180 minus theta, then this is theta. First you make theta over here. So gradually, if this is theta, opposite side of theta was y. Opposite side of theta will be, this particular side will be also y. Isn't it? Isn't it? Okay. If this was y, actually, opposite side, same by, we are going to use the same particular congruency over here, ASA. Opposite side of theta is y, opposite side of theta over here will be also y. Automatically this much distance will become x itself. Okay, this much distance will become x itself. Okay, otherwise the thing is very simple. Either you locate in this manner, or you can create first theta also. First you will create theta, then figure out what is 180 minus theta. Okay, first you will create this particular theta, then figure out what is this 180 minus theta. That is also fine. You're creating some theta over here, and then you're figure outing what is 180 minus theta. Anyway, same idea. 180 minus theta, total is 180, then 180 less than something less than 180. So over here I have considered this 180 minus theta. Okay, if this is 180 minus theta, then this is definitely, this is theta, isn't it? Definitely this is theta. Okay, clear? So gradually we have got the coordinates. Over here we have x is negative, so this coordinate will be what? This coordinate will be minus x comma y. Minus x comma y. On the x-axis, x is negative over here on the second quadrant, and y is positive, so over here minus x comma y. Now come down to this thing, sine 180 minus theta. What is sine 180 minus theta? Sine 180 minus theta in this case, this will be perpendicular by hypotenuse. Hypotenuse is basically r, so y by r. Y by r. Now what was y by r? Y by r was sine theta. Originally y by r was sine theta. From this first diagram itself, y by r was sine theta originally, and cos 180 minus theta, which was cos 180 minus theta, will be what? Base by hypotenuse, so x by r. Okay, x by r. But here x is negative, so we put a minus sign, minus x by r. Minus x by r. And x by r was what? Originally x by r was how much? Cos theta. So this is minus cos theta. Is this clear to all? So we have got this formula, sine 180 minus theta is sine theta, cos 180 minus theta is minus cos theta. Clear? So you can find out tan 180 minus theta also. Tan 180 minus theta. Tan 180 minus theta will be sine theta by minus cos theta, or like definitely this will be minus of tan theta, isn't it? Is this clear? 180 minus theta is clear. Okay. First, the thing is, you need to locate the angle. Angle is located, everything is fine. Locate the angle. Next, 180 plus theta. Come down to 180 plus theta. Come down to 180 plus theta. This is number D, Bodhana. This is number D. Number D, 180 plus theta. Reduction formula for 180 plus theta. Again, locate the angle. Now 180 plus theta is easy angle. 180 half rotation, then something plus theta. Some theta you need to proceed. Very easy. You, by the same logic, we proceed. Bigger circle I am taking just for convenient to draw the diagram over here. Now this is our triangle. Okay, this is theta, and this is coordinate x comma y. This much distance is x, this much distance is y. Okay, This much is the radius r. So 180 plus theta. 180 plus theta means, where is theta located? Angle is, first locate the angle, pi plus theta. So pi plus theta, this much is pi, and then plus theta somewhere over here. Obviously, this will locate in the third quadrant. So you will create the triangle in this manner. This manner. This will be the triangle actually. Okay. This is 180. Total is 180. This is 180 plus theta actually. 180, half rotation, then plus theta. Clear? So over here, this way you are creating the triangle. Okay. Obviously, now one thing, if this is theta, then this is also theta. If this is theta, this is also theta. Vertically opposite angles are equal, isn't it? Vertically opposite angles basically. If this is theta, so this is also theta. Simple. Now you have located theta now over here. In this new triangle, you have located theta. So now gradually you can figure out with this particular same level of congruency. Theta's front side is y. Theta's front side, this much will be y. Okay. Angle theta, we have angle theta, front side of angle theta is y. So front side of angle theta is y. Front side of theta is y. So gradually if this is y, so clearly this definitely must be x, isn't it? This definitely must be x. Okay. So over here on the third quadrant, what we have, the coordinates will be how much? Minus x comma minus y. Minus x comma minus y. On the x-axis we have x coordinate, y-axis. Through along the y-axis we have y coordinate basically, and x and y are both negative in the third quadrant. So we have minus x comma minus y. Simple. Again the same logic. What are we trying to figure out? This is your r distance basically. This is the radius r. What are we trying to figure out? Sine 180 plus theta, sine 180 cos 180 plus theta basically. This is what we need to figure out over here, right? Sine 180 plus theta, sine 180 plus theta, and cos 180 plus theta. Sine 180 plus theta and cos 180 plus theta. What is sine 180 plus theta? Now we can see from here. Sine 180 plus theta from this particular diagram will be minus y by r, perpendicular by hypotenuse. So perpendicular is y, minus y basically. Y is negatives in this case. So y, simple y coordinate. Simple y coordinate. That's why we are figuring out this thing, minus x and minus y. Simple y coordinate by r. Minus y coordinate is minus y by r. Now minus y by r means y by r. Basically we are having y by r. So minus y by r means minus sine theta. Minus y by r means minus sine theta. So we have got this formula, sine 180 plus theta is minus sine theta. Okay, whatever I am given the proof, take this down. Cos 180 plus theta. What is cos 180 plus theta? Base by hypotenuse. So base is what? Base is x. This is the base. Base is x. Okay, this is theta, right? So base is x. Base is x. X is what? Negative. Basically, I told you to remember in this manner, x coordinate. Cos is what? X coordinate by r. X coordinate is minus x by r. Minus of x by r means minus, originally x by r was basically what? So cos theta. So minus of cos theta. So we have got this formula, cos 180 plus theta is minus cos theta. Okay. If you have got sine and cos, so gradually you can find out what is tan. Tan 180 plus theta. Tan 180 plus theta is actually minus sine theta by minus cos theta. That is actually you are getting tan theta, positive tan theta. Okay. This circle and this triangle thing you will not do in your exam. Definitely. You will see the shortcut also. Just one more last thing. One more last. Similarly, you can derive for 270 plus theta also. 270 plus theta, 270 degree. This much is 270. This much will be 270 and then plus theta somewhere over here. Okay. 270. 180 plus pi by 2 basically. 180 plus 90 you will get 270. Okay. So this much rotation will be 270. This much will be 270. Okay. This much will be 270 plus theta somewhere over here. Here you will get the theta. Okay. Easily you can see the other things over here. Let's do one more thing. Let's do one more formula over here. 360 minus theta, let's say 360 minus theta. Okay. Just last reduction formula. Now from this onwards, this is the last thing. After this, I'll show you the shortcut. You will visualize. You don't need to remember so many things also. Simple visualization. You will remember that particular thing. Reduction formula for this thing 360 minus theta. Last one 360 minus theta. Just for basic visualization, I'm showing you this thing. Otherwise, we could have just moved to the direct shortcut way also. Enough proofs I have given you. Those are enough. But just last one. Now come down to this thing. 360 minus theta. 360 minus theta. First locate the angle 360 minus theta. 2 pi minus theta. 2 pi 360. 2 pi minus theta. Locate the angle first. This is your radius on the first quadrant. You take the triangle in this manner. Okay. This is actually your theta. Coordinate is x comma y. This is radius. This is x coordinate. And this is the y coordinate. Okay. Now locate where is 360 minus theta. So complete rotation is 360. 360 minus theta will be there in the fourth quadrant. Definitely. Complete rotation is 360. The 360 minus theta somewhere over here. Fourth quadrant basically. It's a fourth quadrant angle. Something less than 360. So we have 360 minus theta here. We have 360 minus theta here. This is somewhere over here. We have 360 minus theta. Okay. Not accurately drawn. Bring a free hand. This. Okay. Anyways, so this is your 360. This is your 360 minus theta. This is 360 minus theta. 360 minus theta. This is how we locate 360 minus theta. Here will actually lie the angle. Okay. This is your radius r. This will be the radius r. This is the radius r of the circle. Okay. So what you need to figure out? You need to figure out this coordinate. What is this coordinate? What is this coordinate? X comma y or y comma x or minus x, whatever you need to figure out over here. Okay. Now see, this x remains the same. Only the y will change over here, right? And the y will change over here. Simple idea. X will remain the same over here. Only though this particular y will change. This y will be negative y. Okay, because we are there in the fourth quadrant. Fourth quadrant y is negative, right? X is positive, y is negative. So over here we have y to be this much distance will be y. Simple idea. This much distance will be y in this case. X will remain the same. This particular x base is the same. Only we are changing this triangle. We are flipping the triangle over here with this particular quadrant basically. Concept like that. So over here, what is this coordinate? The coordinate will be x comma minus y. X comma minus y. This is x and this is y. Y is negative. So x comma minus y. This is the coordinate x comma minus y. So as we can find out what is sine 360 minus theta. Sine 360 minus theta will be sine 2 pi minus theta basically. Okay. I'm writing degrees over here, but you need to figure out in terms of radians. Sine 2 pi minus theta. Sine 360 degrees minus theta, that is actually minus y by r, isn't it? Minus y by r. So minus y by r, that is actually minus sine theta. Minus sine theta. Originally y by r was sine theta. So here we have minus sine theta. And sine 2 pi minus theta, same thing. Minus sine 2 pi minus theta is minus sine theta. And then similarly, you can find out what is cos 360. Cos 360 minus theta. Cos 360 minus theta is x by r, base by hypotenuse, x by r. X by r was originally x by r was cos theta. So cos theta. Okay. Clear? So cos 360 minus theta is cos theta. So gradually you can find out what is tan 360 minus theta also. Tan 360 minus theta, this will be minus of tan theta. Simple. Minus sin theta divided by cos theta. So that is simply minus of tan theta. Okay. So likewise, we need to figure out. Now the question is, if for instance, you are getting this thing, you are supposed to figure out, let's say, if you are asked the question, what is tan 37 pi minus theta? Tan 37 pi minus theta. How will you figure out that thing? Tan 37 pi minus theta. This, suppose if this is the question, how will you figure out such larger angles in that case? So we have a system, we have a formula, or we have a visualization. This you need to keep in your mind. Simple. If this is clear, this shortcut is clear, then you can figure out any type of angle. If these type of angles are large, sine 37 pi minus theta, sine 42 pi minus theta, or 40 pi minus theta, sine 47 pi minus theta, 101 pi minus theta. Suppose if these type of angles are asked, what happens in that case? How do we locate such angle? So first of all, what I do, this you can write on as a note or visualization, whatever you want to write it. Come back to the quadrant system. Come back to the quadrant system. Basic visualization. Over here, suppose when you start writing down the angles, basically quadrant wise, okay? Quadrant wise, when you used to write down the angles, where we used to start from, we used to start on the first quadrant, 0, then pi by 2, then pi, 3 pi by 2, and then come back to 2 pi and so on, right? That's how we used to proceed the rotation actually. This keeps on rotating, isn't it? We start from where? We start from 0, okay? I told you, all even multiples will actually come over here and odd multiples will come over here, okay? Now let us extend that same concept over here. Even multiple angles, we start with 0, okay? 0, then come over here, rotation 90 degree, so pi by 2, then half rotation, that is simply pi, half angle, pi, then 3 pi by 2, okay? Then come back to 2 pi again, and then the rotation, if you continue the rotation, this will simply keep on going on, okay? What is the main logic? Basically 0 plus pi by 2, then pi by 2 plus pi by 2, which is 2 pi by 2, that is simply pi. 2 pi by 2 means pi over here, okay? 2 pi by 2, then we have 3 pi by 2, then we have 4 pi by 2. 4 pi by 2 is actually 2 pi. That's how the rotation goes, okay? Try to figure out over here. 0, pi by 2, then 2 pi by 2. Pi is what? 2 pi by 2. Pi is 2 pi by 2. So 2 and 2 cancels out, we have pi. Then we have 3 pi by 2. Then we have 4 pi by 2. 4 pi by 2 is 4 pi by 2. 2 and 4 gets cancelled, so over here we have 2 pi, okay? Then after 2 pi, this will be how much? After 2 pi, 4 pi by 2 is gone. Then this will be 5 pi by 2 next, isn't it? Next will be 5 pi by 2. Basically, if the rotation, if you keep on rotating this thing, okay, then the next will be 5 pi by 2. Next rotation will be 5 pi by 2, okay, fine. Then next will be what? 6 pi by 2. 6 pi by 2 means 3 pi. 6 pi by 2 means 3 pi, okay. Then next will be 7 pi by 2. 7 pi by 2. Then next will be what? 8 pi by 2. 8 pi by 2 means 4 pi, okay, 4 pi. Then this, if you, let's say, if you continue some more terms, let's say 4 pi by, you have got 7 pi by 2. Then we have got 8 pi by 2, so that's 4 pi. Then we have what? 9 pi by 2. Next angle over here, next rotation, this will be 9 pi by 2. Then 9 pi by 2, then post which 9 pi by 2, we have 8 pi by 2, sorry, 10 pi by 2, that's basically 5 pi, okay, 5 pi, 8 pi by 2, okay. Then we have 11 pi by 2. Here we have 10 pi by 2. Then we have 11 pi by 2. Then, and so on, this continues actually. 11 pi by 2, then 12 pi by 2. 12 pi by 2 means 6 pi. And so on, this continues. So you all can figure out over here, I hope this particular rotation concept is clear, how we are actually deriving the angles, okay. Pi by 2, we keep on adding pi by 2 with the angles. That's the main thing. Or you simple remember in this manner, 0 pi by 2, then 2 pi by 2, that's pi. Then 3 pi by 2, then 4 pi by 2, so that's 2 pi. Then once again, 5 pi by 2, 6 pi by 2, 7 pi by 2, 8 pi by 2. Then 9 pi by 2, 10 pi by 2, 11 pi by 2, and then this rotation continues. This much is fine, this much angles is fine. What I need to figure out over here, I told you the angles which are actually starting and ending over here, this thing 0, 2 pi, 4 pi, 6 pi. These are our what? Even multiples of pi, 2n pi angles basically, 2n pi. 2n pi angles actually generate from the first quadrant over here. It starts from over here, 0, 2 pi, 4 pi, starts and end over here. All the 2 pi angles, 2 multiples of pi, even multiples of pi angle, 2n pi basically. Okay, starts and end over here. 2 even multiples of pi will actually start and end over here. Okay, then the odd multiples of pi, these will continue actually as you keep on increasing the number of rotations. Then even multiples of pi will actually start over here, end over here. Odd multiples of pi will actually start and end over here, 2n plus 1 pi. Right? Odd multiples of pi. See, 1 pi, 3 pi, 5 pi, next will be 7 pi, then 9 pi. So 2n plus 1 means odd number, 2n plus 1 pi angle will actually end over here. Okay. Now, what about these angles? What about these angles? Figure out these angles. This is what you need to figure out over here. 90 minus theta and 90 plus theta. Sin theta, cos theta, this we have to change in that case. Okay. Sin to cos and cos to sin. We have seen there. Sin to cos and then cos to sin. Tan to cot, cot to tan. Sin 90 minus theta, cos 90 minus theta. This is what you need to figure out for these angles. Now, what are these type of angles? This is fine. This is 2n pi, even multiples of pi, but these are odd multiples of pi. Now, what are these angles actually? 3 pi, 7 pi, 11 pi by, basically 3 pi by 2, 7 pi by 2, 11 pi by 2, and so on. So, what are these angles actually? We need to figure out what type of angles these are in general, basically, like we have figured out over here. In general, these angles are 2n pi angles. In general, these angles are odd multiples of pi angle, 2n plus 1 pi angles. So in general, what are these angles and what are these angles? You need to first figure out. Okay. What are these angles and these angles? Now come down to this one. Pi by 2, 5 pi by 2, 9 pi by 2. Okay. So we have 1, we have 5, we have 9, and so on continues. So gradually, if I write this as 4n plus 1, 4n plus 1 pi by 2 means, what is 4n plus 1 means? All these numbers are actually multiples of, means these are actually of the form 4n plus 1 or 4k plus 1. What is this thing? 4n plus 1 means, suppose you put n is 0. If n is 0, then we have 1 pi by 2. If n is 1, then we have 4 plus 1, 5 pi by 2. If n is 2, then we have how much? This will be 8 plus 1, 9 pi by 2, and so on. So if I write this as 4n plus 1 pi by 2, in general, this is satisfied. Is this clear? Basically, what is the meaning of this thing? These numbers are such numbers, 1, 5, 9 are of such numbers are of the form 4k plus 1. Concept of number theory only. These numbers are such numbers, 1, 5, 9 are such numbers are of the form 4n plus 1. Why this is 4n plus 1? What is the meaning of this 4n plus 1 or 4k plus 1? Whatever you write this n or k. The meaning of 4k plus 1 means this particular numbers upon dividing by 4, remainder is 1. This is the main thing. Upon dividing by 4, remainder is 1. That is of the form 4k plus 1. This is nothing but division algorithm. Simply we call this as division algorithm. These numbers are such numbers, if you divide by 4, then remainder will be 1. This is actually your remainder, 1. This is remainder. Okay. You take any number, let's say 5, you take that number, you divide by 4, remainder is what? 1, you will see. So that's why we write this as 4n plus 1 or 4k plus 1, whatever you write, n or k. Okay, simple concept of number theory over here. So these numbers, 4n plus 1 is pi by 2. These numbers means over here we have pi by 2, then 5 pi by 2, then 9 pi by 2, and so on. These numbers are of the form 4n plus 1 pi by 2. Is this clear? This quadrant is clear. What we are discussing over here. Concept is clear. Simple. We have just simply generalized the angles over here. New concept is there. Just we are actually generalizing the quadrants over here, actually the values over here, angles. Okay. Then come down to this quadrant. Okay. So if this is clear, so come down to this one. 3 pi by 2, 7 pi by 2, 11 pi by 2, and so on. What are these actually? These are of the form 4n plus 3 into pi by 2. If we write this as 4n plus 3 into pi by 2, 4n plus 3 into pi by 2, You see over here, you put n is 0, then you will get what? 3 pi by 2. You put n is 1, suppose 4 into 1 plus 3, 7 pi by 2. Okay. You put n is 3, suppose 4 into 3 plus 3 over here. Okay. Or 2, let's say. You put n is 2. N is 2, 4 into 2 plus 3, 11 pi by 2. So all these numbers are of the form 4n plus 3. Now what is the meaning of 4n plus 3 once again? 3 pi by 2, 7 pi by 2, 11 pi by 2. These are all are of the form 4n plus 3 into pi by 2. Okay. You keep on putting different values of n, you will get the different values of this particular thing. You put n is 1, n is 0, n can be negative numbers also, negative minus 1, minus 2, you keep on putting this, these will be the situations. Agreed with this one? Is this concept clear? So these are of the form 4n plus 1 pi by 2 and these are of the form 4n plus 3 pi by 2. Okay, now what are the meaning of this thing? 4n plus 3 once again. I'll just tell you the number theory meaning of this thing also. You have number theory in your course in case if you are preparing for JEE and all. ISI and CMI. So in number theory, similarly 4n plus 3 and 4n plus 1, these are actually or 4k plus 1 or 4k plus 3. You put n, k, whatever. 4k plus 1, 4k plus 3 are basically numbers of the form 4k plus 3 means numbers upon dividing by 4, remainder is 3, remainder is 1. Remainder is 3 and remainder is 1. This is what I have. Remainder is 3 and remainder is 1. This is remainder is 1, remainder is 3. This identity, this particular last digit is actually your remainder. This is nothing but simple division algorithm. You must have studied in your junior classes also. Simple division algorithm. There is a theorem which states in number theory you will study under division algorithm. That is the first chapter of number theory. You will study that any odd number can be represented either of the form 4k plus 1 or 4k plus 3. And it's a fact. You can see from here 1, 1, 3. 1 can be represented in the form of 4k plus 1. 1 can be odd, 2 let's say, not 2, 3 let's say, odd numbers. 3 can be represented in the form of 4k plus 3. 5 can be represented in the form of 4k plus 1. There is a concept that all odd numbers can be represented in the form of 4k plus 1 or 4k plus 3. It's a theorem in number theory. You may write down as a note also if you want, but not needed right now. We'll see on number theory. All odd numbers can be represented in the form of 4k plus 1 and 4k plus 3. Anyways, let's not go into the number theory concept over here. Now focus on this part. So what we have done, we have simply generalized the angles. These are 2 and pi. Even multiples of pi will actually start and generate over here basically. Odd multiples of pi will come over here. Then 4n plus 3 pi by 2 type of angles will come over here and 4n plus 1 pi by 2 angles will come over here in the quadrant system. Okay. All sine tan cos rule is clear to you. All sine tan cos rule. If this is not clear, all sine tan cos, this must be, all of you must know this thing, all sine tan cos. All sine tan cos rule. Okay. Now come to the main thing. If suppose you are asked some bigger angles like tan 47 pi by 2 minus theta. Okay. Tan 57 pi by 2 minus theta, tan 47 minus theta. Likewise, how will you deal with that case? How will you figure out this is the shortcut I'm telling you. Now suppose over here, this is on this axis, suppose over here, on this axis, on the x-axis over here. Okay, negative, both negative and positive. On the x-axis, if you are traveling on the x-axis, okay, then there is no change. Then there will be no change at all. No change means I'll tell you the change also. What is the meaning of no change and change? First, understand. On the x-axis, if you are traveling, then there is no change. On the y-axis, when you are traveling, then there is change. Then there will be a change. I'm writing over here. If you are traveling on the y-axis, if you're traveling on the y-axis, then there will be change over here. Throughout the y-axis, there will be change. Throughout the x-axis, there is no change. Why? What is the meaning of this thing? Change and no change. Now suppose, understand. For remembering, I am telling you, for shortcut way, you must be remembering in this manner. Shortcut process actually. Okay. When we move on the x-axis, then there will be no change. When we move on the y-axis, okay, y-axis angles basically, this will be change. Now, what is the meaning of change? Change means sine theta goes to cos theta, sine theta becomes cos theta. For instance, sine 90 minus theta, cos 90 minus theta, sine theta. Okay, so sine will change to cos. Understand the meaning of change. Understand the meaning of change. What is the meaning of change? Change means sine will go to cos, sine will become cos, cos will become sine, tan will become cot, tan will become cot, cot will become tan. Then cosec theta, cosec will become sec, sec will become cosec. This is the meaning of change. Okay, I keep under a box just not to confuse with the diagram. This is the change. If you're traveling on the x-axis, these changes will occur. These changes will occur. Okay. Now understand. Suppose, for instance, someone asks you, what is, let me keep this over here. Suppose, for instance, let me write with a red pen over here. Suppose, for instance, someone asks you, what is sine 3 pi by 2 minus theta? Suppose if someone asks you, what is sine 3 pi by 2 minus theta? How will you figure out sine 3 pi by 2 minus theta? Now change or no change, first you need to figure out this. Understand? Sine 3 pi by 2 minus theta. First of all, you have 3 pi by 2. 3 pi by 2 is a simple angle. 3 pi by 2 will simply come over here. This is 3 pi by 2. Okay. 3 pi by 2. This is 3 pi by 2. Over here, 3 pi by 2. Basically, 3 pi by 2 is of the form 4n plus 3 pi by 2. Isn't it? 4n plus 3 pi by 2. So first what you will do? First look at the angle 3 pi by 2. 3 pi by 2 minus theta. So 3 pi by 2 minus theta, this will be over here, right? This will come over here. This is 3 pi by 2. So minus theta will somewhere lie over here in the third quadrant. In the third quadrant. Okay, clear? On the third quadrant. First of all, first thing which you need to check, sine 3 pi by 2 minus theta, there will be change or no change? There will be change. Why? Because 3 pi by 2 is actually lying where? On the y-axis. On the y-axis, as I told you, if you proceed on y-axis, there will be change. 3 pi by 2 is over here on the y-axis, so there will be change. Change means sine theta will become cos theta. So sine 3 pi by 2 minus theta. So first what you will do? First you will write sine theta, sorry, cos theta. Sine will become cos. I told you, if change is there, change angle is this thing, change line is this thing, y-axis. Okay. So if sine 3 pi by 2 minus theta is there, so gradually sine theta, this will become cos theta. This is the change. Now you have to figure out whether this is minus cos theta or plus cos theta. How will you figure out? So first figure out where is 3 pi by 2. 3 pi by 2 is over here. So 3 pi by 2, this will become, so 3 pi by 2 minus theta is over here. 3 pi by 2 minus theta is over here in the third quadrant. In the third quadrant, all sine tan, only tan is positive. All other trigo functions are negative. All other trigo functions are negative, right? Here we have sine. Don't figure out what is cos. Here we have sine. Figure out this thing. We have sine. Sine is negative in the third quadrant, so put a minus sign over here. Is this clear, or shall I explain once again? Yes, minus cos theta. So locate the, basically the things over here, the y-axis or the x-axis. Where does the angle locates? Locate the angle. Okay, figure out where is the angle located. So sine 3 pi by 2 minus theta means 270 minus theta. From the diagram itself, sine 3 pi by 2 minus theta, first locate where is 3 pi by 2. 3 pi by 2 is changing or not changing? There is a change. Where, what is the change? Sine will become cos. So simple, write down cos first. Then we have 3 pi by 2 minus theta. 3 pi by 2 minus theta is a, this is 3 pi by 2. 3 pi by 2 minus theta will come over here in the third quadrant. In the third quadrant, sine is negative, put minus sign over here. Simple. Now once again, take one more example, let's say. I hope this much is clear to you. Simple idea. Take one more example. Let's say, for instance, you are asked to find out, let's say, tan 47 pi by 2, suppose. If you are asked to find out this thing, tan 47 pi by 2, tan 47 pi by 2 minus theta. Now how will you figure out? We have 47 pi by 2, so we have to locate 47 pi by 2, right? We have to locate 47 pi by 2. Just verify whether 47 pi by 2 is of the form 4n plus 3 or 4n plus. First of all, it's an odd angle, right? It's an odd number. 47 is an odd number, right? So definitely either this will be of the form 4n plus 1 or 4n plus 3. So figure out whether this is 4n plus 1 or 4n plus 3. How will you figure out this thing, 4n plus 1 or 4n plus 3? Nearest to 44. What is the multiple of 4? What is that multiple of 4 which is nearest to 47? What is that multiple of 4 which is nearest to 47? 44. 44. Yes, 4n plus 3. Correct, correct. Now minus tan theta na bhul, minus tan theta na, it's not minus tan theta. Odd multiples are odd multiples are there. 47 pi by 2 means 47. Figure out that particular angle, that particular number which is close to 47 and multiple of 4, 44 is there. Simple idea, 44. So 44, basically 44 plus 3 makes 47. And 44 is nothing but 4 times 11 plus 3. That is 47. 44 is basically 4 times 11 plus 3, right? So 4n plus 3, this is of the form 4n plus 3. This is of the form 4n plus 3. So 4n plus 3 will actually come over here, 4n plus 3. So 4n plus 3 means on the y-axis there is change. 4n plus 3, so 4n plus 3 pi by 2 minus theta. Okay, this is 4n plus 3 pi by 2 minus theta. 4n plus 3 pi by 2 minus theta. So 4n plus 3 over here minus theta means over here in the third quadrant same. Okay, now come to the, so first of all, tan is there, odd multiple is there, odd multiples of pi by 2 minus theta. Simple odd multiples of pi by 2 minus theta. Simple change will be there. Tan will become cot theta. Tan will become cot theta minus cot theta. Tan will become cot theta. Now here we have on the third quadrant. On the third quadrant we have plus cot theta. Yes, you are correct. Plus cot theta. I'm sorry. Third quadrant. We are there in the third quadrant. In the third quadrant, figure out what is tan. Tan is positive. So tan becomes cot. So there will be positive sign over here. Positive sign. On it minus cot theta na cot habe. Cot theta, just simply cot theta. So what I am doing, first of all, this is plus cot theta. Why? Because this is a third quadrant angle. In the third quadrant, tan is positive. Tan is positive. So tan is positive. So here we put a plus sign over here, cot theta. Okay. So what you will do so far, first what you will do, first whatever is given, locate even multiples of pi or odd multiples of pi, 4n plus 3 pi by 2 or 4n plus 1 pi by 2. Then figure out whether this is changing or not changing. Change means this change, sine will become cos, cos will become sine, tan will become cot, cot will become tan, cosec will become sec, sec will become cosec. And that's why you used to have 90 minus theta, sine 90 minus theta. What you used to have before, sine 90 minus theta, sine 90 minus theta is cos theta. Why? 90 is over here, pi by 2 minus theta, pi by 2 is over here, pi by 2 minus theta will come there in the first quadrant. First quadrant, sine is positive, everything is positive, right? First quadrant, everything is positive. Sine 90 minus theta is cos theta. So pi by 2 minus theta, first of all, this is pi by 2. Pi by 2 means change will be there. So sine is changing to cos, right? And whether this is negative or positive, this depends on the quadrant. So 90 minus theta will come over here. All means every t ratios are positive. All trigonometric ratios are positive in the first quadrant. So 90 minus theta, sine 90 minus theta means all means everything is positive. So we put a minus sign, plus sign over here, cos theta. Okay. So cos 90 minus theta, sine 90 minus theta, cos theta, tan 90 minus theta, cot theta. Everything will become like why? Over here in the first quadrant, all t ratios are positive. That's why you are getting sine 90 minus theta is cos theta, cos 90 minus theta sine theta, tan becomes cot. Everything is positive. Okay, but for the other quadrants, you need to figure out. So what I am doing first, you figure out this thing whether it is changing or not changing. So change it. If it's changing, change it. Change to tan to cot, cot to tan. Change it. and then figure out whether this is 4n plus 3 pi by 2 or 4n plus 1 pi by 2. How do you figure out? Figure out the number over there for 47. Let's say, hi, I'm figure out in this thing. 47 is given. Figure out what is the nearest multiple of 4. Nearest multiple of 4 of 47 basically. Close to 47. Close to 47. What is the multiple of 4? So 44 is there. 44 plus 3 is 47. That's how I am actually deriving. Is the concept clear? Shortcut is clear to all. You all will follow this shortcut. Follow. Shortcut is clear. I hope the shortcut is clear. Always figure out in this manner. Now see. Now suppose for larger angles, suppose. Now come down to one more concept. For larger angles, very large angles, let's say. Okay. Let's say 330 degrees. 330 degrees. Okay. 330 degrees. For very larger angles, what we'll do? For very larger angle, it is always expected from you to convert angles with terms of this axis, this axis, this axis. Why? Because there is no change on this axis. What I'm trying to say, for instance, suppose, for instance, if I take one or two examples, sine 330 degrees, sine 330 degrees. Okay, I'm figuring out in this thing. How will you find out sine 330 degrees from here? Understand from here. Whenever we have such types of things, sine 330 or sine very large angles, let's say 540 or something, 560, 570 like this, 575 like this. What we do? We convert to find out the value. We convert in such a manner. That there is no change. It is actually expected from you to convert using this particular x-axis only, because throughout the x-axis there is no change. If you convert using with the help of pi by 2 or 3 pi by 2 or something like this, let's say you try to convert to minus pi by 2, something like this, 3 pi by 2 minus theta or something like this, then there is a problem. It is difficult to change with respect to the y-axis. Why? Because you have, first of all, you have to change from sine to cos, cos to sine like this. You have to change first. Then you have to see the quadrant and whether it is 4n plus 1 and so on. So it is better you change using with respect to the x-axis. Now what I'm trying to say using this thing, what is change with respect to x-axis? Suppose over here, you also minus half. Yes, correct. Suppose over here we have first one is sine 330 degrees over here. Okay, sine 330 degrees. Follow the quadrant system. Quadrant must be very clear to you. Visualize quadrant. 0, 2 pi, then 4 pi, 6 pi, and so on. Then over here, odd multiples of pi. So here we have pi, 3 pi, 5 pi, then 7 pi, and so on. Okay. Then here we have the 4n plus 3, 4n plus 3, pi by 2 angles, and here we have 4n plus 1 pi by 2 angles. Basically we have pi by 2, right? Pi by 2, then you put then we have 3 pi by 2. 3 pi by 2 will be here, right? Then we have 5 pi by 2, 5 pi by 2. Then we have 7 pi by 2, 7 pi by 2, and so on. Likewise the angles. Okay. Then we have 11 pi by 2 and so on. Now what is the main idea over here? What is the logic what I'm trying to derive over here? Understand? We actually take the changes with respect to the x-axis, because here we have no change. Okay, no change. What is the meaning of no change? Because of this no change, what we do, sine 330, we can write sine 330 as sine 360 minus 30. Sine 360 minus 30. 360 means 2 pi. 360 means 2 pi. Basically this is 2 pi. 2 pi minus 30. 2 pi minus 30 basically. Isn't it? So if you change with respect to this axis, basically 2 pi over 2 pi is over here. 2 pi is over here. 2 pi means there is no change. Sine, cos, tan, whatever. There is no change at all. Sine will remain sine. Cos will remain cos. So sine 2 pi minus 30, 2 pi minus 30, 2 pi is over here, right? So 2 pi minus 30 will lie over here, right? 2 pi minus 30 will lie over here. So 2 pi minus theta, basically. Theta is 30 in this case. So 2 pi minus 30 will lie over here. 2 pi, complete rotation will be 2 pi and 2 pi minus theta. Okay. So likewise over here, in the fourth quadrant, what we have, all sine tan cos rule must be very clear to you. All sine tan cos. All sine tan cos. In the fourth quadrant, what is positive? Only cos is positive. Sine is negative. But there will be change? No change. Why no change? On the x-axis, there is no change. So 2 pi minus theta, this will be simply minus sine 30. Minus sine 30. Simple minus sine 30. Why? Because sine is negative in the fourth quadrant. In the fourth quadrant, only cos is positive. Cos and sec is positive. Otherwise, sine is negative. Sine is negative, so we have minus sine 30. So minus sine 30 means this is minus half. Sine 30 is half, so we have minus half. Clear? This is how you will figure out. So it is better to actually figure out using angles, basically angles, figure out angles using this particular no change axis. Okay. Either try to represent this in terms of pi plus theta or pi minus theta, 2 pi plus theta or 2 pi minus theta. Try to figure out in this manner, because there is no change on the x-axis. For instance, if you ask that why can't we change using this y-axis, pi by 2 plus theta, we can also do this pi by 2 plus theta or pi by 2 minus theta, some sort of thing like that, 3 pi by 2 minus theta. Yes, you can do that, but that is difficult. On this y-axis, everything is changing, means tan sine will become cos, cos will become sin, right? Everything is changing, so it is difficult in that case. You need to figure out the quadrant also. You need to figure out whether this is changing or not changing also. Okay, so that will be a difficult task. So that's why it is always expected for you to change using this particular axis, no change axis, basically. Now you all tell me, sine what to give? Let's say sine 225. Tell me what is sine 225? Value of sine 225. Degree. Sine 225 degree I am giving you. What is sine 225 degree? Correct. Panit, Shorab, correct. Baki there? Others? Sine 225 degree. You are getting minus 1 by root 2. Correct. Minus 1 by root 2 is the right answer. Simple. Again, think of no change axis. Can I make it 2 pi something, 2 pi minus theta or 2 pi plus theta? 2 pi plus theta won't give, because 2 pi is simply 360. Pi plus theta or pi minus theta? Pi minus theta will not work. Pi plus theta will work. Definitely pi plus theta will work. Here we have, this is 225, right? So I can write this as pi plus 45. I can write this 225 as pi plus 45, isn't it? Pi plus 45. This is nothing but sine pi plus 45 degree. Well, 180 plus 45 basically. Either you write it in pi or sine 180 plus 45. 180 degree plus 45. Theta is 45. Okay. So pi plus 45 means pi is over here. Pi plus 45 means third quadrant. Third quadrant, sine is negative. So this is minus sine 45. Minus sine 45. Minus sine theta. Sine pi plus theta is what? Minus sine theta. So sine minus of sine 45, this is minus 1 by root 2. Khatam. Simple. Now you tell me sine 600 degree. Sine 600 degree. Sine 600 degree. Follow? Sine 600 degree. Sine 600. This is a nice one. Sine 600. Minus root 3 by 2. Okay, let's verify. Let's verify. We're getting different answers. Let's verify. Sine 600, I am telling you, sine 600 root 3 by 2. Okay, you're getting root 3 by 2. So sine 600 basically, first of all, best thing is I'll tell you sine 600. Sine 600 is, chalo, you divide by 90, suppose. Divide by 90, suppose. If you are dividing by 90, let's say. Okay, 0 cancels out. We have 60 by 9. If you divide 600 by 90, so if you are dividing by 90, total 540 it is going, right? 540 turns it's going. Total 540 turn this will go. Then 540 plus something, right? 540 plus something. Basically, how much? This is actually 340. Sorry, 540. That's 3 pi. 3 pi this will go. With 3 pi this will go, right? 3 pi this will 3 pi plus 540 plus 60. Can we think of this manner? 540 plus 60. Total 540 is going, total 540. Total 540. So 540 plus 60 means basically if we locate this angle in this manner, let me show you from here. So total we have 600 basically, right? So if you divide by 90, total 540 turns, this will definitely move, right? Total 540 means what I'm trying to say. First this turn, entire total turn, and then over here. Here comes 540 actually. Here comes 540. 3 pi is there. So 540 is there. Okay. So 540 plus theta. 540 plus theta. You think of this manner. 540 plus theta. Isn't it? So sine 3 pi plus 60 means 6 times pi by 2 plus 60. Okay. Clear? So 6 times pi by 2 plus 60. You think of this manner. 6 times pi by 2 plus 60. 6 times pi by 2. Why 6 times pi by 2? You think of this manner. 90 once again. 90 once again. 1, 2, 3, 4, 5, then 6. So 6 times pi by 2 means 3 pi. Isn't it? 6 times pi by 2 means 3 pi. So over here we have sine 6 times pi by 2 plus 60. This is 3 pi only. Directly we have sine 3 pi plus 60. And 3 pi plus theta means third quadrant. In the third quadrant, what we have, sine is negative. This is minus sine 60. Minus sine 60. So here minus root 3 by 2. You are getting minus root 3 by 2. Onit was right. Minus 3 by root 3 by 2. Okay. So you first divide by 90. Best thing in this manner, you see how many 90 rotations it's moving actually. How many 90 rotations it's moving. If you are dividing by 90, up to 540 this will go. Meaning 3 pi. Up to 3 pi this will go. 90, 0 to 90. Then 90 to pi basically. तो 90 plus 90 plus 90, तो 1 2 3 4 5 6, total 6 times pi by 2. It's moving on 6 times pi by 2 plus theta. In this manner you think of. Okay, or let's say, suppose for instance, if you are giving this angle, let's say if you are giving this angle, fourth one, let's say, tell me what is sine 1030 degree. Sine 1030 degree, follow, what is sine 1030 degree? Divide by 90, see how many 90 rotations is completely going, and locate what is theta. Easiest will be in this manner. How many 90 rotations is this going, and then locate theta. Okay, what is sine 1030 degree? Sine 1030. I think a very bad angle I have considered. Anyways, if you're getting something, you tell me what you're getting. Minus sine 50 minus sine 40. Minus 50 our minus sine 40. Achha, let's verify. 1030 degree. So 1030 means over here, best thing is you all are trying, very nice to see. 1030. So figure out 1030 means over here, how much? First you divide by 90, suppose. If you divide by 90, how many times, how many 90-degree complete rotations it's making? How many 90-degree complete rotation this is making? If you divide by 90, 0 cancel out, 103 by 9. 103 by 9. Okay. So 103 by 9 means how many rotation it's completely moving? 11 pi by 2. 11 pi by 2. How? See, 11 pi by 2 plus 40. This we can write it as 1030. Basically, we have sine 11 pi by 2, 11 pi by 2 plus 40. Will this work? 11 pi by 2 plus 40. 11 times 90 basically plus 40. Now 11 is basically what we are thinking in this manner. This is 11. 11 means a number of the form 4k plus 3 or 4n plus 3, basically 4n plus 3, isn't it? You put n is 2, so we'll have 11 pi by 2. 11 pi by 2 plus 40. We can think of this manner. 11 pi by 2 plus 40. So complete 11 pi by 2 rotations it's creating. 11 pi by 2 rotations. 11 pi by 2 rotations. This way. 1, 2, 3, 4. Then 5, 6, 7, 8. Then 9, 10, 11. 11 pi by 2 will lie over here. Somewhere over here we have 11 pi by 2. 11 pi by 2. So 11 pi by 2, very close to pi by 2 angles I'm thinking of in this manner. Close to pi by 2 angles. Close to pi by 2 we have 11 pi by 2. 11 pi by 2 plus 40. 11 pi by 2 means we have 11 times 90, that's 990 plus 40. 990 plus 40 is 1030. Okay. In this manner, I am thinking 11 pi by 2 plus 40. Clear with this? 11 pi by 2 plus 40. 11 pi by 2 plus theta. Theta will lie over here. Theta will lie over here in the fourth quadrant. In the fourth quadrant, what is? We have, first of all, we have what? We have 4n plus 3 pi by 2 plus 40. 4n plus 3 pi by 2 plus 40 means this is, first of all, we have sign, odd number, odd multiples of pi by 2, change will be there. Change, simple change. Now see the quadrant. This will become, sign will become cos 40. This will become cos 40. Okay, this will become cos 40. So minus or plus, sine 11 pi by 2 plus 40, fourth quadrant sign is negative, put minus sign, simple. Minus cos 40 is the right answer. Minus cos 40. Okay. Now 40 is not a standard angle to find out the value of this. So what you will do? So basically what happens in your JEE or some standard exams, basically they will follow this thing only. But no change axis. Figure outing angle in the no change axis in this manner. The first one, okay, 180 plus 45, 3 pi minus theta, 3 pi plus theta, likewise over here they will try to give you. But sometimes they will trick you. They might also give these type of angles also. These type of angles also in terms of odd multiples of pi by 2. You have to figure out odd multiples of pi by 2. Okay. First three were easy. Last one was 1030, 11 pi by 2 plus 40. You might also need to think of in odd multiples of pi by 2 also. So this depends upon which practice of these angles actually. Let's do some more questions of these angles. Let's say you tell me what is the value of tan 19 pi by 3 suppose. Tell me what is tan 19 pi by 3. First. Tan 19 pi by 3. Tell me. 19 pi by 3. Think of change with respect to the x-axis. There is no change. Change with respect to x-axis. Think in this manner. 3 pi, 2 pi. Correct. Basically 19 pi by 3 we can say in this manner. 19 pi by 3 is actually tan 6 pi plus pi by 3. 6 pi plus pi by 3. Tan 6 pi plus pi by 3. Isn't it? Tan 6 pi plus pi by 3. Tan 6 pi plus pi by 3. Over here we have 18 pi plus pi. That is 19 pi by 3. So 6 pi means we have even multiples of pi. Even multiples of pi over here. Let me remove these things. This was easy to visualize over here in this manner itself. Easy angle. 19 pi by 3 is given. 6 pi plus pi by 3. 6 pi means over here 6 pi. Pi by 3 plus pi by 3. 6 pi plus theta means in the first quadrant. In the first quadrant everything is positive. Okay. First of all, no change. 6 pi plus theta. No change. Even multiple plus theta. No change. So tan. This is the same as tan pi by 3. That's root 3. Pi by 3 means basically your 60 degrees. Tan 60. Okay. So always do think in this manner. Now you tell me, suppose next one. You solve such questions of these type to clear out your basic things over here. Otherwise, we will next thing is only to move on to the main part of your trigonometry. Next, we'll start off with compound angle formulas. Okay, a lot of discussions we have done under allied angle formulas and all. What of things we have done. Now we are going to move on to with some question solving sessions. We are going to move on to allied angle compound angle formulas. Next, you try out. Let's say what to take. Let's say sine minus 11 pi by 3. Sine minus 11 pi by 3. You tell me what is sine minus 11 pi by 3. Acha, one more thing. I hope you do remember this thing. Sine minus theta is minus sine theta. Cos minus theta is cos theta. Only cos is changing. I hope you all do remember this thing. I have told you, na, this thing, this particular change. Cos minus theta, only cos is changing. Only cos is the even function. Cos minus theta is cos theta. Only cos and sec will not change. Otherwise, everything will be sine, will be minus sine of minus theta will be minus sine theta. I hope I have told you these things in the first lecture. Not in the first lecture, second or third lecture, most probably. Okay. Just a bit recap of this thing. First you do this one, then I'll tell you. Sine of minus theta, I hope you do remember this thing. Sine minus theta is minus sine theta. You can take out this minus sign and then solve and tell me what is the value of this thing. How much are you getting? Koto asche on it, root 3 by 2. Root 3 by 2. I think minus yes, root 3 by 2, correct. Root 3 by 2. Root 3 by 2. Easy one. We have sine minus 11 pi by 3. So what do? You take minus common, because sine minus theta is minus sine theta. Sine 11 pi by 3. Sine 11 pi by 3. Sine minus of sine 11 pi by 3. And this is actually minus sine 11 pi by 3 means this we can write in this manner, 11 pi by 3. So first of all, we have a odd multiples of pi. 4n plus 4n plus 3. 4n plus 3 pi by 3. Odd multiples of pi. And what you can do to convert this thing with the help of the x-axis, means no change axis. You can think of this manner. Total, let's take 4 pi. 4 pi with respect to 4 pi, suppose. Multiples of pi, suppose I'm thinking of in this way. Multiples of pi minus theta or plus theta. Multiples of pi, suppose I take 4 pi. 4 pi means 4 into 180 minus pi by 3. 4 pi minus pi by 3. Can I write this as 4 pi minus pi by 3? 4 pi minus pi by 3. 12 pi minus pi, that's 11 pi by 3. So 4 pi minus 3, this will be 4 pi minus 3. 4 pi minus pi by 3, this will be 4 pi means this thing. 4 pi, this is 4 pi. 4 pi minus theta means fourth quadrant. Fourth quadrant sign is negative. So this will be minus of minus sine pi by 3. So minus minus will get cancelled out. So this will become plus sine pi by 3. Sine pi by 3, which is simply root 3 by 2. Root 3 by 2 is the right answer, not minus root 3 by 2. Root 3 by 2 is the right answer. Okay. I hope you all do remember this thing. Just a brief recall of this negative angles, in case if you do remember. If you see any negative angles over here, like over here we have discussed this thing. If this is theta, then this was minus theta, right? That's what, sorry, this was minus theta. Okay, and this is actually lying on the no change axis, right? On the no change axis. In the no change, x means x-axis. On the x-axis overall there is no change. If this is theta, then this is minus theta. So sine minus theta, cos minus theta, then we have tan minus theta, then cot minus theta, then sec minus theta, then cosec minus theta. These are actually what we need to figure out. Okay, sine minus theta. If theta is this, then this is minus theta. So what is sine minus theta? Mechanically, we have seen the formal proof before. Now see with the shortcut proof also. No change axis. If this is theta, this is minus theta. So sine minus theta is what? First of all, on the no change axis, there is no change. Simple no change. First of all, no change. Sine theta will be sine theta, cos theta, tan theta. Okay, cot theta will be cot theta. Since we are there in the no change axis, this is no change. Okay, if this is theta, then this is minus theta. That's how we write it. Then cot theta is cot theta. Okay, sec theta will become sec theta. Cosec theta will become cosec theta. Now plus or minus, this we need to figure out on the no change axis. Okay, on the no change axis. Sine minus theta is sine theta or minus plus sine theta or minus sine theta. This we can actually see from this particular concept of no change axis itself. How? We have no change. Sine minus theta means over here in the fourth quadrant sine is negative. Okay. In the fourth quadrant, cos minus theta, in the fourth quadrant, cos is positive. In the fourth quadrant, tan minus theta, cos is negative. Cot is also negative. In the fourth quadrant, basically, we are over here actually, minus theta, and there is no change. Minus theta. In the fourth quadrant, cot minus theta will be minus cot theta. In the fourth quadrant, sec minus theta will be plus sec theta, because in the fourth quadrant, cos and sec are positive. In the fourth quadrant, cosec minus theta will be minus cosec theta. Okay. These are the things which we have done the formal proof before using the triangle minus theta plus theta, and this is the mechanical way. How do we understand using the shortcut also? Okay. If you remember this shortcut also, then also you don't need to remember this thing. Otherwise, students do remember in this manner. Only cos and sine will, cos and sec will not change. Otherwise, every other things will change. The sign will change actually. Change means the sign will change. Sine minus theta is minus sine theta. Cos minus theta is cos theta. Sec minus theta is sec theta. Only cos and sec will not change. The remaining sign will change actually. Okay. This is what we have done in the first class, and this is the mechanical way to remember, the shortcut way to remember in this manner. If we follow by this particular thing, particular diagram over here itself. Where do we use this actually? Suppose, for instance, if suppose someone asks you the question, what is in the place of you are doing 2 pi minus theta, okay, you are doing 3 pi minus theta, you are doing 20 pi minus theta, 30 pi minus theta. For instance, suppose someone asks you, what is theta minus 20 pi? What you will do in that case? Suppose if someone asks you, what is the use of these identities actually, this particular note. If suppose someone asks you, what is theta minus 20 pi? Ulta, opposite of this thing. Sine 20 pi minus theta, no. Sine theta minus 20 pi, suppose someone asks you. What you will do? You will simply take out one minus common from here. Minus take out minus common. So this is 20 pi minus theta. Okay. This will become 20 pi minus theta. So gradually sine minus theta, we know this is minus sine theta. So minus will simply come out. So this is sine minus of sine 20 pi minus theta. Okay. And this is actually minus of sine 20 pi minus theta. 20 pi means even multiples of pi, no change, even multiples of pi, isn't it? 20 pi will lie somewhere over here, isn't it? 2n pi, 2n pi, 20 pi will lie somewhere over here, no change, 20 pi minus theta. So 20 pi minus theta will be in the fourth quadrant. Fourth quadrant sign is negative. Fourth quadrant sign is negative. So this is minus sine theta. So minus will cancel out. So this is simply sine theta. So sine theta minus 20 pi and sine pi minus theta, 20 pi minus theta, this will be sine theta. Okay. Yeah. Simple logic. In the previous lecture, we have done the proof of this same thing using not the previous lecture, previous to previous lecture, most probably. We have done using the triangle diagram for these two quadrants by locating. Concept was the same. Now we are simply writing this thing with the help of the shortcut which we have learned. No change and the change shortcut, the change criteria basically. Okay. So let's do some more questions. What was the last one? Sixth one, sine minus 11 pi by 3. So chalo, next one. Seventh one, continue with the questions. Seventh one, suppose what to give. Find out what is cos minus 1710 degree. Find out what is cos minus 1710 degree. 1710 degrees. Find out what is cos 1710 degrees. You can think of multiples of pi minus theta or plus theta. You may think of this manner. Multiples of pi minus theta or plus theta. Simple angle is there. 1710. Multiples of pi minus theta. Multiples of pi close to 1710. Figure out. Multiples of pi close to 1710. Pi means 180 degrees basically. It's given in degrees. So 180 degrees. Multiples of 180 degrees close to this thing. Close to 1710. Okay. Cos minus 1710 is given. Follow fast. Value of this thing. Root 3 by 2. Now root 3 by 2 bhul. Root 3 by 2 is wrong. Yes, 0. Let's verify. 1710 degree. So cos minus of something is given. So you can directly write this as cos theta. Cos 1710 degree. Cos 1710 degree. Okay. So multiples of 180 basically, multiples of pi which is close to 1710. Multiples of pi close to 1710 is what? You figure out. Multiples of pi close to 1710. What is that? 1800, let's say. I take 1800, 10 pi. 10 pi. 10 pi means 1800 basically. Can I write this as 1800 minus 90? Can I write this as 1800 minus 90? 1800 means 10 pi. Right? It's the same as cos 10 pi minus 90. So cos 10 pi minus 90 means 10 pi means even pi. Even multiples of pi. Even multiples of pi on the no change axis. Even multiples of pi means where? Even multiples of pi minus 90. Which quadrant? Fourth quadrant. Right? Fourth quadrant. Even multiples of pi minus 90 means fourth quadrant. So we have this to be fourth quadrant is what? Fourth quadrant cos is positive. So we have cos 90. This is simply cos 90. Cos 90 means 0. Okay. Now suppose you tell me that, sir, suppose we can keep the minus sign and then also we can work out. If we do not remove this minus sign, can we still work out with the question? If we do not convert minus cos minus theta to cos theta, suppose if we do not do this thing, if we do not do this only, keep the minus sign and then work out. Yes, you can also do that. Suppose for instance, if you do not change into this manner and you want to keep the minus sign inside and then work out. Yes, you may definitely do it. For instance, I want to keep this minus 1710 degree. Okay. Then I can very well write this as cos minus 1800 plus 90. Cos minus 1800 plus 90 minus 10 pi plus 90. Isn't it? Minus 10 pi plus 90 will give you minus 1710. Right? Cos minus 10 pi plus 90. I'm keeping the minus sign. Suppose you want to say that I forgot to take this thing. I forgot to change into cos minus theta to cos theta. I am keeping this minus sign inside and then I'm working out. So nearest to minus 1710. What is the multiple of pi? Multiple of pi. Nearest to 1710. What is the multiple of pi? Obviously 1800. That's 10 pi. 10 pi minus 10 pi plus 90 will give you minus 1710. Minus 10 pi plus 90 will give you 1710. Minus 1710. Clear? So minus 10 pi. Now figure out minus 10 pi is given. Now minus 10 pi is where? Minus 10 pi is nothing but minus 10 pi. If this is, let's say, if this is the quadrant. Okay, this is 2n pi. And this is 2n plus 1 pi. Means 0, 2 pi, 3 pi, sorry, 2 pi, 4 pi. 4 pi, 6 pi, 8 pi will all come over here. And over here, odd multiples means pi, then 3 pi, then 5 pi, 7 pi will come over here. Understand in this manner, all the even multiples of pi will come over here. Negative will also come over here. If you think of this manner, minus 10 pi is what? In the clockwise rotation once you take. So minus 10 pi will also come over here, minus 10 pi. Right over here, if you proceed on the negative side, then in the clockwise rotation sense, clockwise means angle is negative. In the clockwise sense, angle is negative. So 0, minus 2 pi, minus 4 pi, minus 6 pi, minus 8 pi, minus 10 pi will also come over here. Will also come over here. N can be negative value also if you take the clockwise rotation in this case, right? Will also come over here. So minus 10 pi will very well come over here, and 10 pi minus 10 pi plus 90 will go back to the which quadrant? First quadrant. First quadrant cos is everything is positive. So this is simply cos 90. Cos 90 is 0. Same thing. Clear? But whenever it's a common logic, you do remember this thing. Cos minus theta is given, so generally it's better to not keep this minus sign and simply work out with this theta over here. Okay, just remove this minus sign, convert this to theta. Now you tell me, solve one more. Cosec minus 1410. Cosec minus 1410. Follow. Cosec minus 1410. First of all, we have cosec. Cosec changes. Changes means sign changes. Cosec minus theta is minus cosec theta. So you may use that, or you may keep this minus sign and then work out. It's up to you. Then solve cos 495. And 10th one is solve sine 1230. Solve these three for your classwork right now. Cosec minus 1410, cos 495 degree, sine 1230 degree. Answer for 8th one. 8th one is follow answer. Yes, correct. 2. Oishi correct. Anusha correct. Then who else? Shorop correct. 2 is the right answer for the first one. 8th one, sorry, not the first one. 8th one is 2. Simple. You may write this as minus cosec 1410. Okay, minus 1410 is there. To take out this minus, cosec minus theta, we know cosec minus theta is minus cosec theta. Okay, keep this minus outside, so we have minus cosec. Now 1410 is there, so close to multiples of pi. Close to multiples of pi means close to this 1410. What is the multiple of pi actually? Close to 1410. What is the multiple of pi? Close to 1410, 1440. Sorry, 1410. What is the multiple of pi? 1440. Then we have 4 times 360. 4 times 360. 4 times 360, that is 1440. 1440. 1440 minus 30. Can we think of this manner? 1440 minus 30. Okay, 1440 minus 30. So 1440 minus 30. Why I am thinking in this manner? 1440 is basically 4 into 360. 4 into 360. I'm dividing by 360. How many times it's going in 360 manner? 4 times 360, we have 140. 1440 minus 30. So this is actually cosec 4 times 360 minus 30. So 4 times 360 minus 30. This is actually minus was there. Sorry, minus sign was there. So cosec 4 times 360 minus 30. So 4 times 360 means 2 pi. So 2 pi times 4 means minus cosec 8 pi minus 30. 8 pi means even multiples of pi. Even multiples of pi means no change. No change. 8 pi minus 30. 8 pi means first quadrant. So basically 8 pi means over here 8 pi. 8 pi means over here 8 pi. 8 pi minus theta means in the fourth quadrant. In the fourth quadrant cosec is negative. So over here this will be negative. So this is minus of minus cosec 30. Cosec 30 means cosec pi by 6, which is 2, because sine 30 is half. So cosec 30 will be 1 by half, which is 2. Minus minus cancels out. Answer will be 2. Very good. Those who have answered. Second one answer. Acha, you have given answer. Anisha is saying how much? 1 by root 2. No, it's not 1 by root 2. Oishi minus 1 by root 2. Correct. Minus 1 by root 2. Cos 495 degree. Simple. Minus 1 by root 2. Cos 495 means we can think of this manner. Cos 495. 95, 495. 360. 2 pi. 360 plus 135. You can break by parts and then solve also. 360 plus 135. Okay. So cos 360 plus theta. 360 means 360 plus theta means first quadrant. First quadrant, everything is positive. So this is the same as cos 135. Okay. Cos 135. Again cos 135. You can further break cos 135. Cos 135 is cos 90 plus 45. You can break in this manner. Cos 135 is cos 90 plus 45. 90 plus 45. 90 plus 45 is 135. So 90 plus 45 means pi by 2. Pi by 2 plus 45. Change. 90. Change. There is a change because we are there in the pi by 2 means on the y-axis. Pi by 2 plus theta. Second quadrant. First of all, this will change to sine. This will become sine 45. Minus or plus. All sine. Second quadrant. Sine is positive. So this is plus. Sorry, negative. Second, this thing is cos is negative. Sorry, not sine. Cos is negative. Cos is negative. In the second quadrant, cos is negative. Cos is negative. So change this minus sine 45. Minus sine 45 means minus 1 by root 2. Oh, you see last one, I think. The last one, half as yes, correct. 1230. 1230 is sine 1230 is half. Again for the last one. Sine 1230 close to multiple. Think of multiples of a very large angle is given 1230. Think of multiples of 2 pi. Think of multiples of 2 pi close to 1230. Multiples of 2 pi close to 1230. Multiples of 2 pi I am saying, not pi. It's a very large angle. You can think of pi also, but think of 360. Multiples of 360 close to 1230. Multiples of 360 into 3, 1080. 360 into 3, 1080. 3 into 360. Okay. 1080 minus 1230 means 150. So plus 150. Further we can convert also. Okay. This is what? Even multiples of pi. Even multiples of pi. And then 150. So this is sine 150. Isn't it? First quadrant. Okay. So sine 150. Sine 150 is what? Sine 180 minus 30. Simple. Sine 180 minus 30. You think of this manner. 180 minus 30. 180 minus theta. Basically second quadrant. So this is sine 30. So this is half. Okay. This way also you can do, or you might have done in some different way. That is also fine. But half is the answer. Sine 30. With this, we finish off with the first part of trigonometry. We shall next enter into compound angle formulas next day.